Hi, and thank you very much for your virtual visit. I will give you a very brief overview of my paper, which focuses on understanding regularization methods for continual learning. As a little bit of background, it's important to know that regularization methods are one of the three main approaches to continual learning. And they are the only option, basically, if our architecture is fixed and if we don't allow replays, and replays anyway are kind of a cheat. So there have been three main algorithms proposed in this domain: EWC, MAS, and SI. There has been quite a bit of follow-up work, but it's basically all centered around these three ideas, combining them or extending them. So we focused on these three methods, and quite surprisingly, we found that all of them are quite closely related. So even though they look very different from the outside, they all approximate a version of the Fisher information and are therefore quite closely related. If you are familiar with the algorithm SI, it might also be interesting for you to know that SI is biased, and the bias is actually the reason why SI works so well. And now you might wonder how I came up with these claims. Well, we do mathematical derivations to show that these algorithms are closely related, but we also carefully empirically validate them on standard benchmarks and settings. On the one hand, this is a nice result because it unifies the regularization approaches that have been proposed so far. And it also explains why some of them work, which was not really known before. And on a practical level, understanding these algorithms gives also some technical insights, which are important if you actually want to work with these algorithms. So if you want to know more details or probe my claims a little further, please do come to my poster session.